Hi, hello, good evening everyone. Welcome to Gradeup. Welcome to the session Startup Series 2021. How are you all guys? So students, please join the session quickly and mark your presence. I am waiting for you all. I can see Rajshekar, Srinivasan, Kanu, Balaji, Prem Ranjan, Anshika Singh, Chetan Shukla, Vishal 21475. Yeah. Good evening, all. So, in the last class, we have discussed about process life cycle, right? So, what is a process? And in the process life, what are the different stages that it undergo? We have seen. Today, we will understand more about this process, and along with processes, we will try to understand threads also. So before getting into the session, guys, this is a gentle reminder for you all, a gentle request also for you all that for this corona prevention, please do wash your hands frequently at regular intervals of time. And this is how you need to wash your hands at least for 20 seconds. Like once you apply the soap, then wash your hands thoroughly, both the sides of the palm and in between the fingers and thumb and nails also you have to wash carefully. Then use separate tissues for cleaning your hand as well as the tap. Please do practice this and be safe. And for any corona, so guys, stay safe at home. Stay tuned to Gradeup. Prep smart and stay safe. So let's get into the session, guys. This is Satya with 13 plus years of experience, and I have mentored more than 10,000 plus students. I have qualified GATE, certified by CISCO. I'm a PhD scholar and SET qualified also. This is brief about me. So let's get into the session, guys. So this is what we have presented in the last class, isn't it? Yeah, I can see Uma Purna, Techmaster, Anjali Roy, Harshil, Syed, Bharat Reddy. Good evening, all. So this is what we have seen in the last class. In the process life, generally there will be 5 phases. One is the start, ready state, running state, exit state or terminated state, blocked state or waiting state, and these will be the transitions. Any new process will go from start to ready, then the ready process will go to running state, or it may be interrupted and come back to ready state, or if it is waiting for any IO action, then it will be sent to blocked state. Once the wait is over, it will be again sent to ready state. Once the process finish its execution, then it will be moved to terminated state. Now, let us try to understand what are different system calls. Means, I told you already in the last class, how a process calls. So, what are system calls? The means through which the process happens through these system calls, just like function calls. Okay, Manu, good evening. Mahesh, good evening. So what would be the system call if the process, of course, to create a process, create process or fork, you can say. For Windows kind of operating system, one system call. For Unix kind of operating system, another system call. And any born process to switch to from start state to ready state, the system call would be admit. What? Admit. So if you say admit of P1, P1 is loaded into ready state, when loaded into main memory. So admitted into main memory. Ready to running state, ready state to running state. This would be dispatch. What is that system call name? Dispatch. For ready state to running state. And for running state to ready state back, the system call would be either preempt or interrupt. Either can be used, either preempt or interrupt. From running state to blocked state or waiting state, either block or wait. From waiting state to ready state, readmit. The system call name is readmit. And from running state to terminated state, exit. And I told there is one optional state for any process, that is a suspended state. The system call itself is suspend, to terminate a process. So you can say even create, terminate. Then admit is the system call for moving a new state from ready state. And suspend is the system call for blocked state to. Whenever we have this number of states, like new state, ready state, running state, blocked state and exit state. In the ready state, there may be many processes, P1, P2, so on. There may be many processes in the ready state. There may be many processes in the blocked state also. At any given time, there may be many processes in the ready state as well as in the blocked state. But how many processes can be in the running state? It is dependent on the number of processes that can run at any given time. The number of processes that can run at any given time, that is completely dependent of processor configuration or CPU. Could you please refresh, guys? Students, can you hear me now? Okay, shall we proceed? There is some technical glitch. It seems like suddenly system got shut down. So that's why I am unable to proceed. I really apologize for this delay, guys. I'm really very sorry, and I'll try not to happen again. Okay. Now, as we were discussing about these system calls, and here when we see the scheduling part, like in the ready state, there can be many processes waiting here. Many processes can be there in the ready state, and many can be there in the waiting state. But in the running state, how many processes should be there? That definitely depends on CPU configuration. For example, if it is a uniprocessor system, only one process can exist in the running state at a time. Okay. Now, when there are many ready processes, which ready process should switch to running state first? Which one first, which one next? Similarly, there are many waiting processes and multiple waiting processes wait is over. So, how the order of blocked processes is decided, which process will go to ready state first, and who decide that? So we will see first who do this scheduling, then how this scheduling happens we will understand. So first we will try to understand who will schedule. That is what we call as scheduler. Schedulers. What these schedulers do? They will decide which ready process to switch to running state. Similarly, which blocked process switch to ready state, or which process to load into main memory first, means which process to load into main memory, that means ready state, from new state to ready state. So the schedulers will decide this transition. Whenever the scheduler decide, then the dispatcher program will carry that process from one state to another state. So here we can say there are basically three types of schedulers. There are basically three types of schedulers. One, long-term scheduler. Two, medium-term scheduler. And three, short-term scheduler. In short, we can call the long-term scheduler as LTS, medium term scheduler as MTS, short term scheduler as STS. So let me call these in with the short notation LTS, MTS and STS. Okay. Now which scheduler does what? Let us try to understand. The short term scheduler will decide this ready state to running state. That means which process to allocate CPU. So the short term scheduler is also known as CPU scheduler. Okay, short term scheduler. Then medium term scheduler, this decides which blocked process to switch to ready state first. So this transition will be decided by the medium term scheduler, and long term scheduler will decide which new process to admit into main memory. This transition is decided by long term scheduler, which new process to admit into main memory. And this is also known as job scheduler. Job scheduler. So basically there are three types of schedulers: long term, medium term and short term. Okay. Okay, I can see Chetan Shukla, from new to ready. STS will not decide, Chetan. STS will decide from ready to running, which process to switch first to running state. That is decided by STS. Okay, guys, any doubts in this? Any doubts in this? You can proceed. You can ask me now. Before I proceed, are there any doubts in this? So which scheduler is also known as CPU scheduler? Short term scheduler. And which is also called as job scheduler? Long term scheduler. Okay. Any doubts you can ask me now. Otherwise you can just type proceed. Nagashivudu, it increases degree of multiprogramming. Okay, LTS increases degree of multiprogramming and STS decreases degree of multiprogramming. Right? Correct? Harshil, running to blocked, there is no need to schedule, because whenever we take for a uniprocessor system, only one process will be there in the running state. So when there is only one process, there is no need of order. So Harshil, Even if you take multiprocessor also, every core will have its own scheduler, its own scheduler logic. So even for a multiprocessor also, for its core only one process is there. So there is no need of ordering from running to blocked. Satish, dispatcher is the common program which will carry the processes from one state to another state. Like ready state to running state, yes, dispatcher, that is understood. New state to ready state, like let me put it here. New state to ready state, who will carry is that is called loader program. Loader program. Ready state to running state, that will be carried by dispatcher. Running state to ready state, that will be carried by interrupt service routine. Interrupt handler program will carry this, will perform this. And running to blocked, running to blocked state, this also will be carried by dispatcher. But blocked to ready, this will be carried by, again loader. Okay. So Nallamalu Satish, I think this clears your doubt. Okay. Next one. Next is about thread. Before we go for scheduling criteria, what is a thread? The bookish definition is very simple, that is a lightweight process. A lightweight process is called thread. This is the definition of a thread, and it is represented as the lightweight. So this is how we represent thread, just as a thread, of course. But if you do not understand with this definition, let me give you one simple example. When you are all watching, let us say, a movie or something through a player. Let us suppose this is a player application. Like currently you are watching my video, right? In a YouTube app you are watching. So this is the application. YouTube application means program. Whenever this gets run, this becomes process. So whatever you are looking at now, this is process. Now in this process, if you observe, you have a chat box, right? You have a like button, you have a dislike button, you have share button, you have subscribe button, and you have some other options to make this chatting. And you have mute button, voice control button, volume, I mean to call volume button, and you have full screen button. So these every independent entity you can call as threads. Every independent entity you can call as a thread. All together, this process is formed. I hope this example given little more clarity for anybody who did not get the idea about thread, right? So now, what are different types of threads? Basically, we can say there are two types of threads. User level threads, ULTs, kernel level threads. What? User level threads and kernel level threads. Right. Now, as the name indicates, kernel level threads, which run in the kernel mode, system mode, or privileged mode. User level threads which run in the user mode. While executing a user process, whatever the threads that are created, we call them as user level threads. While executing a kernel process. So the term itself is related, self-explanatory term is given. Now, if you observe the difference or the relation, differentiation, comparison, whatever you name it as, between a process and a thread, you can clearly see if the context switching takes place from one process to another process, it takes more time. But from one thread to another thread, it takes less time. As I said, guys, by the way, for user level thread, you can have one example as Java threads. In Java programming language, we have multi-threading concept. I believe everybody remember that. So Java threads are created by us. They are user level threads. Kernel level threads, system threads. So like operating system, like Windows, operating system related threads we can call as kernel level threads. Okay. Yeah. So to switch from one thread to another thread, obviously it takes less time because it's of lightweight, means of a small module. But to switch from one process to another process, definitely it takes more time. And sharing, memory sharing. Processes are totally independent and don't share memory. That means each process has its own memory space. But threads may share. When we mention may here, it means may not also. So a thread may share some memory with its peer threads. So threads may have some common space, but processes will not. And the inter-process communication takes more time compared with inter-thread communication. And if you see blocking, if a process gets blocked, remaining processes can continue execution because they are independent. All processes are totally independent processes. Again, sorry, I can't say all processes. Cooperative processes are there, independent processes are there. So if independent processes we take, if it gets blocked, remaining processes will not affect. But when you take a user level thread, when a user level thread gets blocked, all of its peer threads related to that process also gets blocked. So if a process P1 has 3 user level threads and a process P2 has 2 user level threads, so if T3 gets blocked, T2 gets blocked and T1 also gets blocked, but T4, T5 will not affect. So if one user level thread gets blocked, all its peers, means related to that process, gets blocked. And resources which require more resources, that we can quite understandable, more memory. This memory itself is again a resource. CPU time, because it's heavy weight, process takes more time, more resources compared with threads. And dependency, independent processes exist, but as threads are part of a process, they are dependent. Data and code sharing, processes have independent data and independent code segments, but thread share data segment, code segment, files, etc. And creating a thread, terminating a thread comparatively, relatively takes less time than processes. Okay. Satish, a program like C, Java, converted to single process or multiple process? Good question. That is definitely based on your program. If your program is divided into multiple modules, if a program has only main function, then you can have single thread. Multiple user defined functions, multiple functions you have, multiple modules you have, then multiple threads. So that is completely based on your program. Okay. Like how a process has process control block, even a thread also will have thread control block. Like process ID, there is a thread ID. Even thread lifecycle is also there. Thread lifecycle also will be there. Almost of similar phases. And there will be some other state called span state. But when the time comes, I will explain this thread lifecycle. Okay. And it is also having what next gets executed and what registers it has hold. What is the priority of a thread? When you see this term thread priority, definitely students, you might have recalled this Java multi-threading. Get priority, set priority, default priority is 5. What this minimum priority 1, max priority 10, right? And pointer to process that created this thread. Because a thread will not get invoked on its own. First the process should get invoked, along with the process thread also should get invoked. So every thread will have a reference to the process. So that reference will be maintained, and one process may have references to different threads. So all those references will be maintained. Right? Now, while discussing questions on these processes and threads, we will discuss more on it. Now, scheduling criteria. whether you take long-term scheduler or medium-term scheduler or short-term scheduler, how do they schedule? How they decide that this is first, this is next? How they decide the order? So what is the criteria they follow? Let's see. Firstly, there will be, every process will have a parameter called burst time or execution time or CPU time. So what is that? The time of processor required to complete. What is the burst time or execution time? The total time of CPU that is required for a process to get completed. This is one parameter based on which scheduling is done. And another parameter we can have as waiting time. Waiting time. That means the process that spends the time, the process spending duration in waiting. So in blocked state plus ready state. How long the process is in the blocked state and ready state, both together. This is what we call as waiting time. And then we have turnaround time. Turnaround time. What is this turnaround time? The total time taken by the process. The total time taken by the process to finish. That means the difference between burst time and turnaround time is that, let's say a processor wants 5 seconds to complete, but a process took 7 seconds to complete. That means what is the 2 seconds of time? It did wait. So what you can say here, turnaround time is equal to, so turnaround time is equal to what? Burst time plus waiting time. Burst time plus waiting time. Or there is another formula to calculate turnaround time. What is that? Completion time. When a process gets completed minus arrival time. Completion time minus arrival time. So what is arrival time? What is arrival time? The next parameter is this, arrival time. The time at which process loaded into main memory or ready state. So what is this arrival time means? When process arrived into main memory, that is called arrival time. From then till it gets completed, that is what the time it took, right? So turnaround time is what? Completion time minus arrival time or you can calculate in other way as burst time plus waiting time. You can calculate using either formula. Okay, and then throughput. Throughput is another parameter we can say. What is throughput? Number of processes executed per unit time. This is throughput. So by allowing which process first, or in which order if processes are allowed, switched, throughput is more. In which process, if the in which order the processes are allowed, throughput is becoming more. In that order, scheduling may happen. So following all the criteria definitely may not be possible, guys. That's why we have different algorithms. For example, we have one algorithm. First in, first out. So what is the design criteria? What is the base for this algorithm? Arrival time is the base. Right? Similarly, we have another algorithm. Shortest job first. What is the criteria for this algorithm to schedule? Burst time. Means which require less time. Shortest job. So which require less time, that process is allowed first. So like this, one algorithm has one or two criteria following. Basically, scheduling criteria means these 5 parameters. What are they? Burst time, waiting time, arrival time, turnaround time, and throughput. These are the basic scheduling criteria. So what are different algorithms we have, and what is the criteria for them, we will see in the next class. So next class we will see that scheduling algorithms. Okay, so that's all for today, guys. I hope this session added some knowledge to you in operating systems. So again, it's a reminder about this green card. Try to get this green card so that you can access all mock tests. Okay. Yeah, Chetan, that is what we will see. What are the practical difficulties to consider these criteria when we are discussing with algorithms? We will definitely discuss all the possibilities and feasibilities. Okay, Chetan? So that's all for today, guys. Manu Goyal, yes, what source means I already told you. In our Gradeup website or Gradeup app, every day one free test. Every day we are giving you a free quiz, a daily quiz we call it as. So you can attempt this daily quiz every day. This is one source, right? And we are providing mock tests for this NILIT. I think you are NILIT aspirant, that's why I am telling. Mock test, series of mock tests. That is what we call as a test series. multiple mock tests will be there. And if we start a course, there will be weekly tests also, subject wise tests also. So this is one biggest resource for you. Gradeup would be a biggest resource for you. If you want any additional resource, I already told you, MCQs by Timothy Williams. Okay. I mean, does process ever use secondary memory or not? Ranveer, when virtual memory it is using, that means it is using the portion of secondary memory, right? No, Midhun Kumar, you are wrong. From ready state, main memory portion started. Later on, secondary memory is the past phase to main memory. Means after secondary, main memory is there in the hierarchy. After main memory, there is no secondary memory intervention at all. So, in that terminology to say, I can say after ready state, while it is running, process is in the registers or cache memory. When it is in the waiting state, it is back into main memory. Understand? So, this is how it happens. Virtual memory will also involve sometimes. Yeah, Nagashivudu, that priority based on the priority also scheduling happens. We will see that in the next class. Okay. So guys, again, don't be panic about corona. Take preventive measures. Stay safe at home. Stay healthy. Stay tuned to Gradeup. Good night, everybody. See you in the next class. Till then, prep smart, score better, go Gradeup. Thank you.